All right, welcome back to the Math Concepts. What we're looking at today is we want to learn how to factorize using the greatest common factor to the seventh. Let us say we have this, and the intention is that we want to factorize this. What we want to look at is one, we want to do it by using the greatest common factor. All right, so let's take a look at the coefficients. So we have 28, 35, and we have 63. A very quick way that we could find out what number works for this, if there is a number, is that we're going to take a look at the smallest number here. So we have three coefficients there. One is 63, the second one is 35, and 28. We're going to focus our attention on the smallest one, which is the 28. We're going to try to find all the factors of 28. And if we find all the factors of 28, we're going to see which ones from the largest to smallest could divide into the other two numbers without a remainder. And the largest one will be used. So if we're listing the factors of 28, it's going to be from 28. We're going to have a 14. We're going to have 7, 4, 2, and 1. These are all the possible factors, right? Or factor pairs, we could identify them here. These are the possible factor pairs that can go into 28 without a remainder, which means that one of this should work. Now let's focus on 28. Can 28 be divided in 35 without a remainder or 63? Well, if you check, you're going to realize that no, we're going to get a decimal. So 28 cannot evenly divide into these numbers. So we're going to go to 14. Can 14 evenly divide into those numbers? No, it can't either. All right. So we keep checking. 14 can't work. Let's try 7. Can 7 go into 35? Yes. Can 7 go into 63? Yes. So 7 will be the highest common factor of all three numbers. So for the coefficients, we're going to be using 7. Now let's take a look at the letters. If you notice, we're seeing X and Y, which is common all the way. I'm seeing XY, XY, XY. All right, so that means X and Y, they are common variables. But we're going to have to take a look at the power for each. We have to take a look at the exponent for each letter. The lowest power of the exponent will be that greatest common factor. So let's take a look. We're looking at x to the third, x to the fourth, x to the eighth. X to the third is going to be the smallest power here. And then for the y's, we're going to realize that, hey, it's going to be y to the second power. So this monomial here is my GCF. I'm just going to put it underneath. This is my GCF. Now, remember that whenever you factorize, you're going to take your GCF and you're going to use it to divide into all the terms from the system. For example, we're going to divide this by 7x to the third, y to the second. Then we're going to divide this by 7x to the third, y to the second. Then we're going to divide this by 7x to the third, y to the second. We're going to use our greatest common factor to divide into all of these monomial, and then the result is going to come in our parentheses there. Let us go. Let us start. So we could start off by saying 7 into itself, that's 1. 7 into 28, that's 4. So we definitely know that we're going to have a 4 here. But x to the third here would fully cancel x to the third one time. And y to the second will go into y to the fourth, leaving y to the second. So the term that is left is 4y to the second. Just in case if you're wondering what happened with the x, If you have the same degree that divides into itself with the same variable, it becomes 1. So that means there is no more x, right? 1 times 4 still gives us back 4. Let's see what's going on here. 7 into itself, that's 1. 7 into 35, that is going to be 5. So 5 will be the number here. Let's take a look at the letter x. X to the third into x to the fourth. When you divide, you subtract powers. So imagine to the fourth, then the third is subtracted, you're left with 1. So this is x to the 1, but x to the 1 is the same as just x. Now take a look at the y. This is y to the second divided by y to the second. Anything that divides by itself give you 1, right? So 1 times 5x is still 5x. Let's take a look here. 7 into itself 1, 7 into the 63, that's 9. I'm having a negative 9 coming here. Let's take a look at the letter x. X to the third could go into x to the 8. We're going to subtract, leaving 5. Remember, when you divide, you do subtract the exponent of the same letters, right? So in this case, we're looking at x to the 5th power. Lastly, y to the second into y to the 7th. 7 minus 2 becomes 5. So we're left with y to the 5th power. At this stage, we close our parentheses. And so we're seeing here that we have factorized by the greatest common factor. Let's take a look at another one. First thing first, we want to observe these coefficients. We need to find one number that can go into 16, 54, and 32 if possible. All right, apart from number 1. So if we should exclude number 1, we're looking for another number. The largest one, that is. So let us see if we could find one. So let's list the numbers out. So remember, because we want to find the greatest common factor, the focus is on the smallest number, 16. The number that we're looking for must be able to go into 16 as well as those larger numbers, which means if I find the largest number for 16, that could go into 32 and 54, then that's my greatest common factor. So let us list all the factors of 16. So we have 16 times 1. You could put it in pair form if you want. We actually have 8 times 2. And there's a 4 times 4. These are the possible pairs that actually multiply to give us the 16. So there are many ways you could list them. But the bottom line is you want to make sure that you have all those factors that could go into 16. We will be choosing from these. So let us start off by choosing 16. So we're going to move from greatest to smallest. So can 16 go into 32? Yes, it can. 16 go into 32 2 times. But will 16 be able to evenly divide into 54? No, that's the problem. So 16 could have worked with 32, but it cannot work with 54. And that means that 16 is not the greatest common factor. Let's take it out. Let's go with 8. Can 8 go into 32? Yes, 4 times. Can 8 goes into 54? Let's divide it. Take your calculator, check it. Is it to 54? Check it. Well, no, it can't work either, right? So 8 cannot go into 54. Now let's try 4. I'm just showing we tried. So can 4 go into 32? Yes. All right. Let's see again. Can 4 go into the 54? No, we can't. There is a remainder. So 4 cannot be used. And at this time, definitely 2 will be our greatest common factor right now. Can 2 go into 32? Yes. Can 2 go into 54? Yes. So right there, we're seeing where 2 is the greatest common factor. So we're going to write the 2 here. And now, so that is going to be for the coefficients. Let's take a look at the letters. Are we noticing anything? We're noticing A, B, A, B, A, B. So A and B is actually scattered at those three terms. So I'm going to have A and B here. But I'm not just going to leave it. I need the right exponent to go with this. Let us take a quick observation on the lowest power for A. There's an A to the 8, A to the 7, A to the 3. Okay, A to the 3 will be my power for the A. It's the lowest power of the variable. Let's look about our B. We have B to the 6, then there's just a B, and then there's a 4. If you do not see a power, that means this is 1. So then we're suggesting that B is okay as is. B to the 1 is the same as just saying B. At this moment, we're going to open a parentheses because we're going to divide throughout, right? We are going to divide every term by 2, A to the third B. Let's take a look. So at this moment, we're going to try to cancel. Can 2 go into itself? Yes. Can it go into 16? 8. So we are having an 8 here. Now, A to the third will cancel into A to the 8th. So we have A to the 5th. Because remember, when you divide the same letters, we subtract their exponent. And then a B into B to the 5th, into B to the 6th, we're left with B to the 5th right here. Now let's check. 2 into 54, that's 27. And then A to the third into A to the 7th, that's 4. B cancel B fully. There's no B in this section. 2 into 32, that's 16. And then A to the third would have canceled A to the third fully right there. So that's 1. So there's no A here. B into B to the fourth is B to the third. We're left with B to the third. And at this moment, we're done. Here it is. We have just factorized by using the greatest common factor. Remember, when you're choosing what number works for the coefficients, take a quick look at the lowest or the smallest number, find all the factors for it, and then start to eliminate from greatest. Which one would have divided evenly in the other numbers? All right? And the largest one that does it wins. Thank you for watching Daily Maths Concepts, and I'll see you next time. Algebra 1. Bye-bye.